Let's look at this precipitation reaction example. We're going to predict what the products are based on the charges of the ions. We need to know the charges of each of the ions on the left-hand side of the reaction, and we will assume that the ions will keep those same charges on the right-hand side of the reaction. Potassium is a +1 because it's in group 1A. Iodine is a -1 because it's in group 7A. Nitrate is a -1, which we know from memorizing our polyatomic ions. The lead that is paired with the nitrates is a +2. We know it's a +2 because nitrate's a -1, and there are 2 of them in the formula. If we've got a -2 total on the right side of the compound, that means we must have a +2 total on the left side of the compound. Since there is only one lead ion, it gets the full +2 charge. Once we know the charges of the ions, we're going to predict that they switch partners. This is going to be a double replacement reaction. If they're switching partners, the potassium is going to go with the nitrate, and the lead is going to go with the iodine. Remember, positive still must go with negative. Once we predict which ion goes with which other ion, and we know their charges, we can do the crisscross rule. The +2 lead goes with the -1 iodine. The 2 from the lead goes down next to the iodine as its subscript, and the -1 charge from the iodine ends up as an understood subscript of 1 on the lead. We end up with PbI2 as one of our neutral ionic compounds. With the potassium +1 and the nitrate -1 coming together, we end up with just KNO3 as our other neutral ionic compound. Double check that all ionic compounds are neutral. Now that we've predicted our products using the crisscross rule to make neutral ionic compounds, we can balance our equation. In this case, we need a 2 in front of the potassium nitrate and a 2 in front of the potassium iodide. When we put those 2's in, we have the correct number of each thing on each side. Double check that the equation is balanced. Each side has 2 potassium ions, 2 iodide ions, 1 lead ion, and 2 nitrates. After balancing our equation, we need to predict which is going to be our solid precipitate so that we can put in our states of matter. To do that, we use our solubility rules. Lead iodide is going to be insoluble in water. Even though halides, such as iodine, are usually soluble, lead is one of the exceptions. Since lead iodide is not soluble in water, we're going to put an S next to it for solid. Potassium nitrate, on the other hand, is soluble in water. Remember that potassium is an alkali metal, so no matter what it's with, it's going to be soluble. Nitrate is one of our ions that's also always soluble. We put an AQ next to the potassium nitrate because it is dissolved in water. Now we can write our balanced molecular equation with the states of matter. We have 2 potassium iodide aqueous and lead 2 nitrate aqueous reacting together to make lead 2 iodide solid and 2 potassium nitrate aqueous. Now that we have our balanced molecular equation with our states of matter, we can turn it into a complete ionic equation by taking everything that's ionic and aqueous and breaking it apart into ions. The potassium iodide aqueous gets broken apart into 2 potassium ions, which each have a +1 charge, and 2 iodide ions, which each have a -1 charge. The lead nitrate aqueous gets broken apart into a lead 2 ion and 2 nitrate ions, which each have a -1 charge. On the right side of the equation, the lead iodide solid stays as is. Remember, solid, liquid, and gas you leave alone. Lastly, the 2 potassium nitrates get broken up into 2 potassium ions, which each have a +1 charge, and 2 nitrate ions, which each have a -1 charge. Remember to continue to include states of matter. We can take that complete ionic equation and turn it into a net ionic equation by crossing off spectator ions. We have potassiums and nitrates that appear on both sides. 2 potassium crosses out with 2 potassium, and 2 nitrate crosses off with 2 nitrate. We're left with 2 iodide ions reacting with 1 lead-2 ion to make lead-2 iodide solid. That becomes our net ionic equation. Again, we're starting with 2 types of ions on the left. They're the exact amounts needed to combine to make the ionic compound solid on the right-hand side. Which of the following precipitates forms when the following reactants are mixed? The reactants that are mixing are Mg parentheses C2H3O2 parentheses 2 aqueous and LiOH aqueous. Is the answer A, MgOH, B, Mg parentheses OH parentheses 2, C, CH3OH, or D, Li parentheses C2H3O2 parentheses 2? The correct answer is B, MgOH2. Again, we're predicting that the ions are going to switch partners. The magnesium and the hydroxide go together. The lithium and the acetate go together. When the lithium and the acetate go together, both of those things are always soluble in water, so that is not going to be our precipitate. The magnesium hydroxide, on the other hand, will be a solid because hydroxides are generally not soluble in water. Since magnesium is not one of the exceptions, that means the compound is not soluble in water. We also have to be careful here that we make neutral ionic compounds. It's not just MgOH. We have to think about the charges. Hydroxide has a -1 charge, so we need 2 of them to cancel out with the +2 of the magnesium ion.